simplify without a calculator. So let's think about our exponent rules. If we're multiplying like bases, what do we do with the exponents? Well, when we multiply it like bases, we add exponents. So we have 2 to the 1/4 times 2 to the 1/3. Okay, I'm going to need a little workspace here because I know I have to add those. So I have to get a common denominator. So I'm going to get 12 as my common denominator. Whoops, that's 2 to the 12. So 1/4 becomes 3/12 and 1/3 becomes 4/12. So when I'm multiplying these like bases, I'm going to add the exponent, so it's going to be 2 to the 7/12. And that's how you'd simplify that first one. Okay, let's look at the second one. We have 5 to the 1/3 times 2 to the 1/3. Well, when we have like exponents, we can write those as cube roots. So we have the cube root of 5 times the cube root of 2. Well, since they're under the same root, we can just combine those to be the cube root of 10, which is 10 to the 1/3. So you can multiply if your exponents are the same, then you can multiply the bases. Okay, what if we have, well, this one you can actually do two different ways. Because they have the same exponent, we can multiply those together and get 8 to the 1/3, but that simplifies to just a very simple answer of 2, because that's asking us to find the cube root of 8. Okay, and now we're going to have like bases and we're dividing. But when we divide, we're going to have to subtract the exponents. So we're going to have x to the 1/4 minus 1/2. Well, that's x to the negative 1/4. Well, we don't want to leave that as a negative exponent, so that's going to be x to the 1/4 all in the denominator. Okay, now something fancy about that, we cannot leave a root in the denominator. So I'm going to have to multiply this to get a whole number. So I'm going to add my exponents. So I'm going to have to multiply the denominator by x to the 3/2, x to the 3/2. Now the reason I'm doing that is because I'm going to get x to the 4/4 in the denominator, or 1. I need a whole exponent, a whole number exponent in an integer in my exponent. I can't leave it as a fraction. And so I end up with x to the 3/4 over x to the 1st, and that's how you have to leave it, so you don't have a rational exponent in the denominator.